I hope you guys are doing good. So I would like to talk about something called the RMA, DRMA, and these things. Like I was been searching in internet and I found something very peculiar. The remote memory access is called RMA. It's a feature of the distributing a computing system that allows for direct access to the memory located on remote node without need of data to be explicitly sent between the nodes. The RMA is often used in high performance computing environments where large amount of data need to be accessed and processed quickly. Uh, on the other end, we have called distributed remote memory access. It's the specific implementation of RMA that allows the efficient access to a remote memory in a distributed computing environment. A DRMA typically involves a specialized network interface card and the software stacks that enable high speed, low latency access to remote memory. DRMA can be used in a variety of ways, but it is most commonly used in HPC, the high performance computing environment for scientific computing and data analysis. For example, DRMA can be used in a simulation that requires a large amount of data to be processed and shared among the multiple nodes. So, in this scenario, DRMA can significantly reduce the time it takes to transfer the data between the nodes and they enable the faster computation time. DRMA is also used in an application that require high performance computing such as financial modeling, machine learning, image processing. These applications often involve processing a large amount of data and require high speed, low latency access to remote memory to achieve an optimal performance. So in summary, RMA and DRMA is a powerful tool that allows an efficient access to remote memory in a distributed computing environment. So it is commonly used in HPC environment for scientific computing and data analysis. So as well as the other application requests and high performance computing. Okay, any in-memory technology uses RMA and DRMA? Yes, there are several in-memory technologies that uses RMA and DRMA to enable high-performance data processing. These technologies are designed to keep data in-memory for fast access processing rather than accessing the data from slower storage device like a disk and SSD. There are some examples of in-memory technologies that are currently using RMA and DRMA. So the Apache Spark, Apache Ignite, SAP HANA, Oracle times 10. So these are the most four popular technologies are using by this particular the remote memory access technology. The Spark is the open source and distributed computing system that is uses in-memory processing to enable the fast data processing. The Spark supports RMA and DRMA operations to enable the efficient communication between the nodes in distributed computing environment. Apache Ignite, it's also a similar kind of in-memory data fabric that provides a high performance computing processing and storage of large data set. Ignite supports both RMA and DRMA operation to enable the efficient communication between the node in distributed computing environment. SAP HANA, HANA, an in-memory database platform that supports real-time data processing and analytics. HANA uses RMA and DRMA to enable the efficient data access and communication between the nodes in distributed computing environment. Oracle times 10, and an in-memory database system that provides a high performance processing storage for real-time applications. The times 10 supports both RMA and DRMA and same as to efficiently transfer the data and the communication between the nodes in distributed computing environment. Okay, there are top 10 technologies currently using this RMA protocol. Basically to have enable a direct access to the remote memory in a distributed computing environment. It is a key technology in high performance computing, used in many technologies to achieve the fast and efficient data processing. Here are the 10 examples of technology that is using by RMA. One is called InfiniBand, high-speed interconnected technology commonly used in HPC systems. InfiniBand supports RMA and enable high bandwidth, low latency communication between nodes. Number 2 is all about Cray Aris, a specialized network fabric used in Cray XC series supercomputers that supports RMA and enable efficient communication between node and distributed computing environment. Third is all about Intel Omni Path Architecture, which is called OPA, High Performance Network Fabric that supports RMA and enable the effective communication between node and distributed computing environment. The fourth, which is called Open SHMEM, an open standard for parallel computing that supports RMA and enable efficient communication between the nodes in a distributed computing environment. The fifth is all about MPI 3 RMA, a standard messaging passing interface that supports RMA and the same as like for having a efficient communication as well. The sixth is all about Unified Parallel CUPC, high performance parallel computing language that supports RMA as well. Seventh is all about Chapel, parallel computing language developed by Craig that supports RMA. Eighth is Global Arrays, a library for parallel computing that supports RMA. Ninth is OpenMPI. It's an open source implementation of MPI standard that supports RMA as well. Fifth is all about GISNet, low level communication library that supports RMA as well. So these are the 10 technologies which is currently using by RMA.